captions in English, please. So this is the 7th video of chapter 7, and it's on gas evolution reactions. So aqueous reactions that form a gas when two ionic solutions are mixed are called gas evolution reactions. Some gas evolution reactions result from the direct combination of a cation with an anion. For example, when you have the sulfuric acid H2SO4 combining with the lithium sulfide Li2S, the gas H2S will be formed from combining the H plus ions with the sulfide ions. And then you will have the salt LiSO4, the lithium sulfate. So here is just the combination of the hydrogen with the sulfide that makes a gas. H2S is a gas and escapes. And so you would see bubbles in this mixture of solutions. Many gas evolution reactions result from an intermediate product that decomposes, breaks down to form a gas. And that's the case of more examples actually. Let's look at an example. When you have HCl, the hydrochloric acid, reacting with NaHSO3, you have the bisulfite ion, the HSO3, combining with the hydrogen, and that's going to give H2SO3. The so bisulfide bisulfous acid. And Na will combine with Cl to form the salt NaCl. And so H2SO3 is unstable in solution. It's unstable and it will decompose. It will decompose into H2O and sulfur dioxide gas. And that's why it's a gas evolution reaction, because you make a gas in the end. So you're forming water and this SO2 gas. So you need to know all those gas evolution reactions that are, typical here. So the first example here is when the sulfide combined with an acid. So we saw the example with HCl when it combines with, for example, here the potassium sulfide. The hydrogens will combine with the sulfide to make the H2S gas, the H2S gas, which will escape. So there is no intermediate product in this case, and the gas evolved is H2S. In the case of carbonate and bicarbonate, carbonate are CO3 negative 2 and bicarbonate are HCO3 negative 1. When you combine carbonates and bicarbonates with acid, like HCl, it can be any kind of acid, but here the example shows with HCl, how the hydrogen combines with the carbonate to form the carbonic acid, H2CO3. And H2CO3 is very unstable and it will decompose into H2O and CO2, the gas, the carbon dioxide gas. And so that's how this is a gas evolution reaction. Same when you have sulfite and bisulfite, SO3 negative 2 and HSO3 negative 1. When you combine them with an acid, it can be any kind of acid that will bring an H plus ions. So the H plus ion will combine with the sulfite and bisulfite and make the H2SO3 acid, or compound H2SO3, and that's so the sulfite, that's the sulfurous acid. It's unstable. It decomposes into water and SO2, sulfur dioxide gas. So very similar to what's happening with the carbonate here, but you change the carbon with the sulfur and it's the same behavior. H2SO3 is unstable and decomposes into water and the gas SO2. And then the last one that is typical is the ammonium. Ammonium is this polyatomic ion NH4+. When you combine it with any kind of base that will bring hydroxide ions, so OH minus ions, the ammonium will combine with the hydroxide and form the ammonium hydroxide, NH4OH. And so this decomposes. Again, it's not stable, and it will decompose into H2O and NH3, which are both two molecules very stable. NH3 is a gas, so that's why it's a gas evolution reaction, because you're forming the ammonia gas. So you need to know these, what they will become. Know that H2CO3 is unstable and will make water and carbon dioxide. H2SO3 is unstable and will make water and the sulfur dioxide. And then ammonium hydroxide is unstable and will make the water and ammonia. And then the H2S is a gas. So let's look at an example of a gas evolution reaction that implies carbonate, that has carbonate in it. So how do we proceed? So begin by writing a skeletal equation that includes the reactant and the product that form when the cation of each reactant combines with the anion of the other. So let's say here you have the sodium carbonate combining with the nitric acid, HNO3. So we've seen in the table that if you put carbonate into an acid, any kind of acid, the carbonate will combine with the acid, the H plus ions. And so the H plus ions with the carbonate forms the carbonic acid, H2CO3. And then the nitrate and the sodium will combine to form the salt NaNO3, which is aqueous in, soluble in water. We know that H2CO3 is not stable. You have to recognize that it decomposes into H2O and CO2, and CO2 is a gas. So write the corresponding equation. So you want to keep your reactant the same, but what changes is that the H2CO3 becomes H2O plus CO2, and CO2 is a gas. So that's why it's a gas evolution reaction, plus the salt NaNO3. And finally, you want to balance the equation. So here we have two sodium in the sodium carbonate. And so because of that, you will need two sodium on the right. And you will have to have a coefficient of 2 in front of NaNO3. And having a 2 in front of NaNO3 means 2 sodium, but also 2 nitrate. And so we need now to have 2 nitrate on the left of the arrow. And that means you need to add a 2 in front of HNO3, because that's the nitric acid that contains the nitrate ions. So this way you have 2 nitrates on the left, 2 nitrates on the right, 2 sodium on the left, 2 sodium on the right. And then the carbonate decomposes into the carbon dioxide and mingles with the hydrogen to form water. So let's go through some more examples. Write and balance the reactions for acetic acid in vinegar reacts with calcium bisulfite solution. So acetic acid, we can retrieve its formula from its name. It's an acid that doesn't have the prefix hydro in front, so it's an oxy acid. The ending "ic" means you have a polyatomic ion ending in 8. And acetic means that it comes from the acetate ion. So you need the acetate ion. It's C2H3O2 negative 1. And it's an acid, so that means it's combining with the H plus. When you combine H plus with the acetate ion, it makes the acetic acid, and the formula is HC2H3O2, and that's aqueous because acids are always aqueous. Reacts with calcium bisulfite. So calcium is a Ca2+ because it's in group 2A, so it's a 2+ ion. And then the bisulfite is HSO3 -1. It comes from the sulfite, which is SO3 -2, but you add an H to it, and that's the bisulfite. So here we need 2 bisulfite per calcium because calcium has 2 positive charges, but the bisulfite has only 1. So if you do the crisscross trick, you see that the formula will be Ca, open the parentheses, HSO3, close the parentheses, 2. And that's aqueous because we have been told it's a solution. So now we want to exchange partners, right? You need to do it the way we've done it for the precipitation reaction. You exchange the partners and find the new combinations, and that will be your product. So the cation of one compound will mingle with the anion of the other compound. So that means the H+ will combine with the HSO3-. And so you see that it's one positive charge, one negative charge. So together they can make a neutral compound. And when you write the formula, it's H2SO3 because you have 2 hydrogens and then the SO3. And so that's the, SO3 -2 is the sulfite ion. So that's the sulfurous acid here. Then calcium will combine with the acetate. Calcium has 2 positive charges. The acetate has only 1. So you need 2 acetate per calcium. So the formula will be Ca, and then the acetate in parentheses with a 2 on the outside to say that we need 2 acetate per calcium to have a neutral formula here. The acetate ion always makes soluble compound. If you look at the solubility rules, the acetate has no exceptions. It's always making soluble compound. So that's an aqueous solution. Now, you should have recognized that H2SO3 is one of those acid that is unstable and decomposes into H2O and SO2, the gas SO2, sulfur dioxide. So you rewrite the equation by changing only the H2SO3 into water, liquid, plus SO2, a gas. SO2 is a gas, and that's why it's a gas evolution reaction. So finally, you need to balance. We see that on the right side of the arrow, we have 2 acetate in the calcium acetate. So we need to make it 2 acetate on the left by having a coefficient of 2 in front of H, C2H3O2, the acetic acid. That makes it 2 acetate on the left, 2 acetate on the right. Calciums are balanced. And now HSO3, there is 2 on the left. We know that they will become the H2SO3. And here we have 2 sulfur on the left. So we need 2 sulfur on the right. So there will be a coefficient of 2 in front of the SO2 gas, and then also in front of the water, because the water and the sulfur dioxide, they come from the bisulfite ion and sulfurous acid. And so that balances this equation here. Second example, nitric acid with sodium sulfide solution. So nitric acid, that's an acid. There is no hydro prefix. That means it's an oxy acid. The ending "ic" tells you that it ends in 8. The polyatomic ion that it comes from ends in 8. And so if you take nitric, it becomes the nitrate. And so you need to find the formula of the nitrate, and that's NO3 -1. So it's an acid, so that means the nitrate is combining with the H plus ion when it's this acid. So H plus NO3 minus 1. One of each ion will make a neutral formula here. So the formula is just HNO3. And that's aqueous because all acids are aqueous. Plus sodium sulfide. Sodium is the Na plus ion, and the sulfide is the S negative 2 ion. Sodium comes from group 1A, so 1 positive charge. Sulfur comes from group 6A, so 6 minus 8 is 2 negative charges. You do the crisscross trick and you see that you get Na2S. You need 2 sodium per sulfide to make this a neutral formula. Sodium always makes soluble compound, and here you are told it's a solution, so it's aqueous. So let's find the product formula by exchanging the ions. They will exchange partners. So let's place the H plus with the sulfide. So together, you can see that if you do the crisscross trick, it's going to be the H2S gas. So you have to remember that H2S is a gas, and that's H2S. So that's a neutral formula when you have 2 hydrogens per sulfide ion. And then you have sodium combining with the nitrate. And one of each ion will make it a neutral formula. So it's NaNO3. And sodium and the nitrate ions are both making soluble compounds with no exception. So we know that NaNO3 is an aqueous solution. Finally, let's balance. So we have 2 sodium on the left. We need 2 sodium on the right. So we will need a 2 in front of NaNO3 to have 2 sodium on the right. This 2 NaNO3 means you have also 2 nitrate now on the right. So we need to make it 2 nitrate on the left. And that means we need a 2 in front of HNO3. And that balances everything because we have 2 nitrate on both sides, 2 sodium, 1 sulfur, and then 2 hydrogens on both sides. Let's do a concept check. So it's for you to practice. So pause the video, try this on your own before you watch the answer. So write and balance the reaction for ammonium bromide solution when it reacts with calcium hydroxide solution. So from the name, you need to find the ions and the compound formula of the reactant. So ammonium is NH4 plus. It's an ion, a polyatomic ion you need to remember. The bromide is Br minus. And you see that each have 1 positive charge, 1 negative charge. So the formula will be NH4Br. That's an aqueous solution. You're told it's a solution. It reacts with another solution of calcium hydroxide. Calcium is Ca2 plus because it's in group 2A. The hydroxide ion is a polyatomic ion you need to remember, and it's OH minus. So when you place them next to each other like this, cation first, anion second, you see that you can do the crisscross trick, and you will need 2 hydroxide ion per calcium. So the formula will be CaOH 2 times. And that's a solution, so it's aqueous. So that's the reactant. Now let's exchange the partners, the ions partners, to find the product formulas. So the ammonium, which is the positive ion, will combine now with the hydroxide, the negative ion from the other compound. NH4 plus OH minus, one of each ion will make a neutral formula. So it's NH4OH. And that's aqueous because ammonium makes always soluble compound, no exception. So, and you keep the formula this way. You don't combine the hydrogens together. You want to recognize the ammonium and the hydroxide. Next, you combine the calcium with the bromine or the bromide. Calcium has 2 positive charges, bromide has 1 negative charge. So you will need 2 bromide per calcium. And you see that if you do the crisscross trick, you get this CaBr2. And that's aqueous because bromine or bromide makes a mostly soluble compound, and calcium is not an exception. So here you need to recognize that the ammonium hydroxide here is unstable and typically decomposes into water and ammonia. So you rewrite the equation by changing now the ammonium hydroxide into H2O liquid plus ammonia, which is the gas. And that's why it's a gas evolution reaction. Finally, you need to balance. And here, so we have 2 bromide on the right, only 1 on the left. So we need to make it 2 bromide or bromine on the left by having a coefficient of 2 in front of NH4Br. So this way we have 2 bromine on the left, 2 bromine on the right. And that changes the number of ammonium on the left. And ammonium, kinds of becomes ammonia. So you need 2 ammonia here. For 2 ammonium, you will make 2 ammonia. And those 2 OH hydroxide ions here will make 2 molecules of water. And those 2 hydroxide ions will combine with the 2 H plus ions from the ammonium when it becomes the ammonia. So you have to have 2 ammonia and 2 molecules of water. And this way it's balanced. Let's look at the second example. Sulfuric acid reacts with sodium carbonate solution. So it's an acid, sulfuric acid. There is no hydro prefix that tells you it's an oxyacid. And the ending "ic," sulfuric, tells you that it should be 8. Sulfuric comes then from sulfate. So you need to find the sulfate ion. And that's SO4 negative 2. That's one of those poly atomic ions you need to remember. And when it's the sulfuric acid, it means that the sulfate combines with the hydrogen ion, H+. So H+ and SO4 negative 2 together will make the sulfuric acid by having 2 hydrogens per sulfate, because you have 2 negative charges, and so you need 2 H+ ions to cancel those charges. Acids are always aqueous, so the state of matter is aqueous. Sulfuric acid reacts with sodium carbonate. Sodium is Na+. Carbonate is the CO3 negative 2 ion. It's one of those polyatomic ions you need to remember. So when you put them together, you can see that you will need 2 Na+ to cancel the 2 negative charges on the carbonate. And you can see that with the crisscross trick as well. So the formula will be Na2CO3. Na2CO3, you are told, is a solution. So now we need to find the formula of the product by exchanging the ions, combining the cation from one compound to the anion of the other compound. So let's have H+ with the carbonate. And so you see that you need 2 H+ per carbonate to make this a neutral formula, and it's going to be CO3 aqueous. That's an aqueous solution here. That's an acid. It's the carbonic acid, because carbonate becomes carbonic acid because you see the hydrogens are first in formula. So that's the carbonic acid. And then we have the sodium combining with the sulfate. We need 2 sodium per sulfate because we want to cancel those 2 negative charges with 2 positive charges from the 2 different sodium atoms. So the formula will be Na2SO4. Na2SO4 is aqueous because all kinds of compounds made of sodium are always soluble. So here you want to recognize that the carbonic acid is unstable and will decompose, and it typically decomposes into water and carbon dioxide, H2O and CO2. So you rewrite everything, but change H2CO3 into water, liquid, plus CO2 gas. The carbon dioxide is a gas, and that's why it's a gas evolution reaction. So finally, you want to make sure this is balanced. Let's see. So we have 2 sodium on the left, 2 sodium on the right, one sulfate on both sides. The carbonate will make the carbon dioxide, and the water will take the other oxygen and combine with the 2 hydrogens that are from the sulfuric acid. So that's already balanced.